The nervous system plays a role in nearly every aspect of our health and well-being. It guides our everyday activities like waking up, getting dressed, texting on our phone, brushing our teeth, eating breakfast, digesting that food, and telling us when we're hungry. It also helps with very complex processes like thinking or reading, our memory, or our feeling of emotions. So it gives us our information and stores information about our previous experiences to help guide us in our future experiences or our current experiences. The nervous system controls our brain growth and development. It helps us interpret sensations like touch or hearing to tell us that something is soft or fluffy, or it's quiet or loud. It also helps perception of different sensory information. It gives us our thoughts and our emotions. It helps with our movement, balance, and coordination, our sleep regulation, our healing and rehabilitation, and the body's response to stress. It also regulates our breathing and our heartbeat and our body temperature. And then it tells us when we're hungry or we're thirsty and how we're digesting. And so when we break the nervous system into different parts, we can think of it as the peripheral nervous system and the central nervous system. The two systems communicate through the stimulation of the environment and the neurons transmitting that information from one nervous system to the next. So neurons give us our pathway so that we can get that information most efficiently from one area to another of the central nervous system. So for our stimulation of the environment, if we put our hand on a hot stove, we have the sensation that something is happening to the sensory receptors on the skin. Those sensory receptors travel the pathway through the peripheral nervous system up to the central nervous system where it's interpreted for that sensation. And it tells us that it's hot, and then it also gives us a command to remove the hand from the hot surface. So that command travels back down the peripheral nervous system through the motor neurons to the muscles and the glands or the organs of the hand for the response for us to remove the hand. You might say, oh, that's all well and great for the hand, but what the heck does that have to do with speech? And really, there are lots of different ways that the central nervous system and the peripheral nervous system are involved in speech, language, swallowing, and hearing. And we can think about it in, first of all, this pathway of stimulation from the environment when we're talking. So if I'm trying to say a word or I'm giving you a sentence and I stumble a little bit over my words, just like I did right there, I get that feedback not only from my hearing system to say that didn't sound right, but also from my sensation of my tongue to the roof of my mouth and the tongue to the lips. So that if I'm trying to say the T sound, but instead I say the K sound, I get the sensation of my tongue hitting the roof of my mouth in the back instead of my tongue hitting the roof of my mouth in the front. And the body sends that information up to the central nervous system where the central nervous system says, no, that wasn't the target sound. And it sends information back down to correct the movement of the tongue to give me the T sound. We can also think of it as storing information for our rules of language. So as we grow and develop, we have to store this information for the English language that says that sentences go in a certain order, and that words have specific meanings, and some words even have double meaning. And so that's kind of our memory. Memory is not just associated with events in our lives, but the rules that regulate our language and our language use. And then for hearing, we also have that feedback of what a person is saying and how we interpret the meaning of a person's messages, not only through the hearing system, but through the sight system if they're using gestures. And then we also get information for swallowing. So similar to what my example was for speech sounds and correcting the K to the T, we also have a sensory pathway that tells us if I'm taking a big bite of food, I need to have a bigger swallow or bigger movements of my swallowing muscles to get all of that big bite down to my stomach, versus if I'm taking a small sip of water, I can have a quicker movement to get that water down to my stomach. It doesn't take as much effort from the muscles. And all of those commands get the stimulation from our sensory environment that says this is a piece of steak in my mouth, it's a little bit harder to chew, this is how long I need to chew it until it's ready to swallow. And then our central nervous system sends a command that says, all right, muscles, get ready. You're going to have to activate and squeeze together to get that food all the way down to the stomach. And that's our motor response. So the peripheral nervous system is divided into three different areas. We have the cranial nerves, the spinal nerves, and the autonomic system. Cranial nerves are really from the clavicle and above. You'll see in this picture to the left they're highlighted in a maroon color. And those give us our sensory and motor movements for the face and the neck. These are the nerves that are going to be most important for speech, language, hearing, and swallowing, and so we're going to talk about those the most, and we really won't focus too much on our spinal nerves or the autonomic nervous system. Now, the spinal nerves are what connect the sensations or get the sensations for the rest of the body. So these are highlighted here in green, and you'll see they go all the way down to the toes and the tips of the fingers. The autonomic nervous system really attaches to many of our internal organs, and it's what regulates our internal environment, so our heartbeat, our breathing, our body temperature, and things like that. The central nervous system composes of the brain and the spinal cord. So the brain is really where we store that information that we have from previous experiences, and those previous experiences help us interpret what's coming in from our environment. The spinal cord connects to the spinal nerves, and it helps the spinal nerves transmit information up to the brain. It also is important for reflexes. So it gives us a quick response so that the information doesn't have to travel all the way up to the brain. It can actually just travel within the spinal cord and go quickly back to the spinal nerves for the reflex response. So what I've done here is divided and given you a little graphic for the division of the central nervous system and peripheral nervous system. So here we have the central nervous system composing of the brain and the spinal cord, and again, remember the cerebrum is the brain. And then we have the different areas of the brain, including the brain stem, which has the midbrain, the pons, and the medulla, and then we have the cerebellum. We also have the peripheral nervous system here with the cranial nerves, the spinal nerves, and the autonomic system. And remember that all of this information through the peripheral nervous system and the central nervous system is transmitted through a neural pathway. So one nerve traveling to the next nerve, to the next nerve, to the next nerve, until it gets to its target spot for interpretation. So again, our neurons are within the brain, within the spinal cord, and also the cranial and spinal nerves. You can see here on the left I have a picture of the brain from the central nervous system and the cranial nerves. And you'll see that the cranial nerves really travel down the neck, and we have one called a wandering nerve that goes all the way down to the intestines and loops back around. But these nerves really attach to the muscles, organs, and skin of the face and the neck, and they connect into the brain through the brain stem. So you'll see here these two areas really do communicate with one another, and these pathways weave in and out of the brain to give us the pathways that they need to get the information where it needs to go for interpretation.